Hello, welcome back to Spanning Tree series. So, this is the first video of the Spanning Tree series, which I am going to be doing. So, I have already published a video on Spanning Tree, which is a quite long video. So, I have decided to do a series on Spanning Tree. So, this is the first video of the series, and you can expect at least 10 videos from this series. So, this series will be completely hands on. So I have a lab setup. So for the entire series, I'll be using the same lab setup which you are seeing right now on the screen. So and I have already published a video on Spanning Tree, which is 1.5 hours, and also I have published a blog on Spanning Tree, and you can find the link in the description. And I have already detailed all the test cases that I am going to be doing in this series in the blog. And if you want to look at the test cases that I'll be doing in this series. You can read through my blog. And so this is the first video. So in my first video, I'm not going to be doing any test cases, but I'll be explaining the lab setup that I have and the default STP configuration which is running on my lab. So I have not done any STP configuration on this lab. So currently all the STP related configurations are default. I just configured uh, a default gateway on the spine, and I have configured some VLANs, some interface configuration on the server. Okay. Other than that, the STP configurations are untouched. I did not even touch STP configuration on any of the switches, except I have changed the spanning tree version from MSTP to RSTP just for simplicity. So Arista by default supports MSTP. So by the way, this lab setup is Arista CUIS. Even the server also I'm using Arista CUIS. So so I have just changed the spanning tree version from MSTP to RSTP for simplicity. And let me explain the lab setup. So I have a spine and two leaf switches and a server. Server is connected to both leaf switches, and E- mm, ET1 on the server is in VLAN 10 and ET2 is in VLAN 20. And server is not participating in the STP. And on the spine is connected to leaf 1 and 2. And between leaf 1 and 2, I have two links. Okay, don't. So I just have these two links for, let's say, MLAG. Let's say in the future, I might be using MLAG. So, so maybe I keep these two links for MLAG in the future. Okay, or for I can say additional redundancy. Okay, so as you can see, the bridge ID are the priority is the same, is the default bridge ID on all the switches. All three switches have the same bridge ID because the priority is default priority. And the MAC address is unique, and you can see leaf 1 has the lowest MAC address. And if you look at the link cost of all the links, the it's 20,000 because it's a virtual lab. So all the links have the same cost, and it is configurable. So we can manually change the cost. So we can also do that, but we are not going to do that in this video. We'll be doing that in the upcoming videos for different test cases. And let me now open the CLI and we'll show it. We'll show you the lab setup on the CLI. Let me go to the spine, show spanning tree, and show spanning tree. Show spanning tree. So as you can see now, right now all three switches are running RSTP, and you can see the priority are, I would say, bridge ID. So all three switches have the same bridge ID, and the MAC address, you can see leaf 1 has the lowest MAC address. So since the first the first deciding factor is the bridge ID, since all three switches have the same bridge ID. So the next tiebreaker is the MAC address, and leaf 1 has the lowest MAC address. So it became the root bridge. And you can look at the interfaces on leaf 1. All the interfaces are designated and forwarding. And on leaf 2, ET3 is the root port, and we have ET1 and 4 are alternative. ET2 is a designated and it's an edge port. So edge port is nothing but a port which is connected to an endpoint. For example, in this case, a server. ET2 on both leaves are connected to the server. So that's why we are seeing the as edge ports here. And on spine 1, ET1 is the root port and ET2 is the designated and forwarding. So let me show you the LLDB neighbor table as well. So LLDB neighbor. So show LLDB neighbor. So you can see the LLDB neighbor table. Uh, on the spine, ET1 is connected to leaf 1, 2 is connected to leaf 2, and on leaf 1, 1 is connected to spine, 2 is connected to server, 3 and 4 is connected to leaf 2, and on leaf 2, 1 is connected to spine, 2 is connected to server, and 3 and 4 are connected to leaf 1. Okay, this is our lab setup. So now let's focus on the default STP. So default STP configuration. Okay, right now, uh, since we have not configured the priority manually, we did not change the priority manually. So all the switches are using this default priority, and whichever switch has the lowest MAC address has become the root bridge. So let me explain the three types of election here that's happening. One is the root election. I would say a root bridge election. So root bridge election, then root port election, then designated port election. So there are three elections happen. And root bridge election happens for the entire STP instance. So it's the radius of this election is the entire STP instance. In this case, the entire all the devices participate in this election. For the root bridge election, all the switches will participate. This entire STP instance. This right now, this RSTP instance. So the entire RSTP instance is participating in the root bridge election. Next, I have root port election. So root port election happens per switch. For example, this is the radius. So the election will be between switches, between ports 1, 2, 3. So these three ports are participating in the root port election. And next, root bridge election. So root bridge election, I would not say root bridge, designated port election. Sorry. So designated port election happens per L2 segment. So L2 segment is nothing but an L2 link. This is an L2 link. So this is one segment. So two segment, three and four segments. So I have four segments here. And since leaf one is the root, so all the links are designated. Okay. So so an L2 segment can have only one designated port. The other should either be a root port or alternative port. So that is the rule. So an L2 segment cannot have two designated ports. For example, if Ethernet 1 is designated, then this Ethernet 1 has to be either root or alternative. So if this ET3 is designated, if this ET3 should be or must be either either an alternative port or root port. Right now, ET3 is root port, and ET4 is the designated for port. And this side, we already have one port on the switch as the root port. So this guy has to be the alternative port because we already have a designated port in the L2 segment. So designated port election happens per segment, and root port election happens per switch, and root bridge election happens per instance. Okay, so it happens per instance. So the root bridge election happens per instance, and root port election happens per switch, and designated port election happens per segment. That's L2 segment. So I have three switches in the instance right now. So right now, what's happening? Since all the switches have the same uh, bridge ID or priority. So the next tiebreaker is the MAC address, and leaf 1 has the lowest MAC address, so it became the root bridge. So root bridge election is completed. Then the root port election. So the root port election happens on the non-root bridges. So it does not happen on the root bridge. So it only happens on the spine and leaf 2, because uh, the rule is leaf 1 is the root bridge. So all the interfaces on the root bridge must be designated port. So by default, all the interfaces on the root bridge will be designated. So it does not participate in any other election because it is the root. So once leaf 1 became the root, then everybody else has to obey the root bridge. So now the root port election happens on the non-root bridges, which is the spine and leaf 2. So on the spine, now the election is between ET1 and 2. So between them, the root port election, it's based on the root path cast. So the root path cast is nothing but whichever port has the best path to the root bridge. So in this case, spine has two paths. One is through ET1 and the other is through ET2. So to reach the root bridge via ET1, the total cost is 20,000. And to reach the root bridge via ET2, the total cost is 20,000 plus 20,000, 40,000. So ET1 became the root port. On, on leaf 2, let's now come to the root port election on leaf 2. Leaf 2 has three parts, 1, 2, 3. So ET1 has lost the election because the total cost is 20 plus 20. But ET3 and 4 have the same root path cost of 20,000. So there is a tie between ET3 and ET4. Then the tiebreaker is the port ID. So ET3 receives the port ID from ET3 of leaf 1, and ET4 receives the port ID from ET4 of leaf 1. So ET3 receives 128.3 and ET4 receives 128.4, and whichever is lower will win. So ET3 is receiving lower port ID than ET4. So ET3 has become the root port. Okay. Now in the segment, now this segment, the election is done. This side is designated and this side is root, and here uh, root, and here everything is designated. Okay. Now it's time to elect the elect the designated port. So a designated port election happens per segment. Right now, this segment is already done. This segment is already done because it's a root port. So next, between ET2 and ET1. So now the first bridge ID, both have the same bridge ID, are priority. Next deciding factor is the MAC address, and spine has ET2 has lower MAC address. So ET2 on spine became the designated, and ET1 on leaf 2 became the alternative. And here, this segment, we already have a designated, which is leaf 1. So ET4 must become the alternative. So hope you are able to catch the election process. So let me go to the lab and I'll show you there. So here you can see uh, uh, leaf 1 is the root bridge and all the interfaces are designated on forwarding. And spine, you can see the cost to reach the root bridge. ET1 has the lowest cost. You can see 20,000. So it became the root. And ET3 and ET4 have the same cost, but ET3 is receiving the priority of 128.3 from leaf 1, which is lower than ET4. So it's become the root port. And between ET2 on spine and ET1 on leaf 2, ET2 on the spine has better MAC address than leaf 2. So spine ET2 became the designated, and ET1 became the alternative. And ET4 on leaf 2 became the alternative because on the other side, it's the root bridge. So root bridge always wins. So it becomes the ET4 on leaf 2 became the alternative. So hope you are able to catch the election process. So this is a default STP configuration on Arista switches. So I'll see you in the next video where we'll be doing one of the test cases. So I'm going to be the first test case is I'm going to be manipulating this election, root bridge election. So we're going to be looking into a root bridge election. So I'm going to be making some other switch other than leaf one as the root bridge. So I will be seeing what other options. How can we make a sort of switch as the root bridge? So we'll be seeing that in the next video. Hope you are hope you are able to follow and continue on the next video. And thanks for watching this video.